Mercury. It is the first planet from our sun. It lives very close to this star. This makes Mercury a world of intense heat, but it's also a world of surprising cold. Its name has ancient roots. The Romans named it after their messenger god. This god, Mercury, was known for his speed. He zipped around on winged sandals. The planet Mercury is also a speedster. It races around the sun. This tiny planet holds a record. It is the fastest planet in our solar system. It travels at an amazing speed, about 47 kilometers every second. That is incredibly fast. Imagine a car going that quickly. Its journey around the sun is short. Mercury completes one orbit in just 88 Earth days. So a year on Mercury is less than 3 Earth months. This swiftness is fitting for its name. It truly lives up to its godly namesake. Observing Mercury from Earth is not always easy. Its closeness to the sun presents a challenge. It often gets lost in the sun's bright glare. You can usually only spot it at twilight, either just before sunrise or just after sunset. This fleeting appearance added to its mystique. Ancient astronomers knew it was special. They tracked its rapid movements across the sky. Its speed made it a celestial enigma for centuries. It darted like a quick thought. Mercury is also the smallest planet. It really is quite tiny in cosmic terms. It is only a bit larger than Earth's moon. Its diameter is about 4,879 kilometers. That might sound big to us, but in the grand scale of planets, it's small. You could fit about 18 Mercuries inside Earth. Its small size and speedy orbit make it unique. A tiny world on a fast track, always rushing, always close to the fire. Look at Mercury's surface. What do you see? Craters, lots and lots of craters. It looks very much like our moon. These craters are scars. They tell a story of ancient impacts. Asteroids and comets have smashed into it. This happened over billions of years. The largest crater is called the Caloris Basin. It is huge, about 1,550 kilometers wide. A giant impact created this feature. It shows the violent history of the early solar system. Beneath this battered crust lies something surprising. Mercury has an enormous iron core. This core is truly massive for such a small planet. It makes up about 75% of the planet's diameter and around 60% of its total mass. Earth's core is much smaller in proportion. Why is Mercury's core so big? Scientists have theories. Perhaps a giant impact stripped away much of its rocky mantle, or maybe it formed this way. It's a puzzle. The surface isn't just craters, though. There are other interesting geological features. Long cliffs or scarps crisscross the planet. Some are hundreds of kilometers long and several kilometers high. These are not from impacts. They formed as Mercury cooled down. The planet actually shrank. Its giant iron core cooled and contracted. This caused the crust to wrinkle and break. Like a drying apple, its skin folded. These scarps are Mercury's wrinkles. Mercury has almost no atmosphere, just a very thin, wispy layer called an exosphere. It is made of atoms blasted off the surface. Solar wind and micrometeoroid impacts do this. This lack of a real atmosphere is important. It means there is nothing to trap heat. There is also no weather, no wind or rain to erode the surface. So craters and scarps remain unchanged for billions of years, a silent, airless world preserving its past. Temperature on Mercury is a tale of two extremes. It is a planet of fire and ice. During the day, the side facing the sun gets incredibly hot. Surface temperatures can soar to about 430 degrees Celsius. That is hot enough to melt lead. You would not want to stand there. This intense heat is due to its closeness to the sun. No atmosphere means no protection. The sun's rays bake the surface directly. It is a furnace, but then night falls, and Mercury becomes astonishingly cold. Temperatures plummet dramatically. They can drop to minus 180 degrees Celsius. That is a huge temperature swing, over 600 degrees Celsius from day to night. This is one of the largest temperature ranges in the solar system. Why so cold at night? Again, the lack of atmosphere is key. There is no blanket to hold in the daytime heat. All that energy radiates away into space, swiftly. Mercury's rotation is also very unusual. It has a special relationship with its orbit. This is called a 3-to-2 spin-orbit resonance. What does this mean? It means Mercury rotates on its axis 3 times for every 2 orbits it makes around the Sun. So 3 Mercurian sidereal days equal 2 Mercurian years. This is a strange dance. It's different from Earth's simple day-year cycle. This resonance was a surprise discovery. It makes Mercury quite peculiar. This unique spin-orbit coupling has a weird effect. It affects the length of a solar day on Mercury. A solar day is the time from one sunrise to the next. On Mercury, one solar day lasts 176 Earth days. That is 2 full Mercurian years. Imagine a sunrise that takes many Earth days to complete. The sun would appear to move very slowly across the sky. Sometimes it even looks like it stops and briefly reverses direction. This is due to Mercury's eccentric orbit and slow spin. Humans have sent spacecraft to study Mercury. We wanted to learn more about this enigmatic world. The first was NASA's Mariner 10 mission. It flew past Mercury 3 times in 1974 and 1975. It was a pioneering mission. Mariner 10 gave us our first close-up images. It mapped about 45% of the planet's surface. It also discovered Mercury's thin atmosphere and its surprising magnetic field. A great start to understanding this small planet. Decades later, another NASA mission arrived. This was MESSENGER. It stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. MESSENGER was the first spacecraft to orbit Mercury. It arrived in 2011. It studied the planet for over 4 Earth years. It mapped the entire surface in high detail. It gathered vast amounts of data. MESSENGER revolutionized our understanding. It answered old questions and posed new ones. A truly successful scientific endeavor. One of MESSENGER's most stunning discoveries was water ice. Yes, water ice on the hottest planet's neighbor. It sounds impossible, but the ice is found in shadowy places, deep craters near Mercury's poles. These areas are permanently shielded from sunlight. They remain incredibly cold all the time. The ice is likely mixed with organic compounds. This discovery was unexpected. It shows that even extreme worlds can hold surprises. Water is resilient. MESSENGER also confirmed Mercury's magnetic field. It is weak. Only about 1% as strong as Earth's, but it is definitely there. Its existence is a puzzle. A planet needs a molten convecting core to generate a field. Mercury's core should have cooled and solidified long ago, yet the field persists. Understanding Mercury helps us understand all rocky planets, including our own Earth. Future missions like BepiColombo will continue to explore. They will unlock more of Mercury's secrets. The speedy enigma still has much to teach us.